problem, we are being asked to find how much energy is transferred into the system by this force. And then in the second part of the problem, we are asked how fast the two blocks are moving.
Alright, so in this problem we have two blocks connected by a string. Block 1 is 12 kilograms, block 2 is 4 kilograms. And we have a force acting 60 degrees below the horizontal. And that is a 250 Newton force. The wall has a friction constant of 0.3. And the block moves 20 centimeters or 0.2 meters. And for a free body diagram, we have four forces. We have the 250 Newton force, we have the force of friction, the force of gravity, and the normal force from the wall.
In order to find how much of energy is transferred by this force to the object, we need to find the work that this force did. So to do this, we use the formula work equals force multiplied by change in position multiplied by cosine of theta, where theta is the angle between these two. So we'll break up the work in two dimensions. Our object is not moving in x direction, so therefore the work is 0 in this case. Then in y direction, our work equals F multiplied by change of position in y direction and cosine of angle between them, which is 30 degrees. And when we plug in these numbers in calculator, we obtain this number, 43.3 joules.
Alright, to find how fast the blocks are moving together, we have to sum the total energies and set it equal to the kinetic energy. So first we have to find the gravitational potential energy, and we do this by adding the two masses of the blocks together and then multiplying it by the acceleration due to gravity, and then the height that it traveled, which is 0.2 meters, and then we get 31.36 joules. Then we have to find the work due to friction, and that is 125, and we got this number from 250 sine of 30, right there in the triangle diagram. And then we multiply it by the kinetic friction coefficient of kinetic friction, and then by how far it traveled for work equals force times distance, and we get 7.5 joules. Then we set the energies equal to the total energy minus the gravitational potential energy minus the work due to friction, and that gives us 43.3 joules minus 31.36 joules minus 7.5 joules, which equals 4.44 joules. Then we take this energy, set it equal to the kinetic energy, which is mass times velocity squared divided by 2. And then here we just solved for velocity and plugged in all of the numbers that we found, and then you get your final velocity to be 0.745 meters per second. Drop the mic. Going up.